Okay, so I'm going to take a slightly broader view, maybe start with some things that we're familiar with, like present forms of procurement, and then look at the past as well as look at the future to see what we can learn from the past and whether that can inform us in how we deal with uncertainty in the future. So to start, what is certainty? If we want to know what uncertainty is, then we need to think about what certainty actually means. So certainty is the quality of being reliably true. So the more certain we are, the less risk we believe we are taking. We can be wrong, but we have this belief that it's not risky if we are quite sure about what we're doing. So, you know, quite often we use expressions like the future looks bright or the future looks bleak, these kinds of things. Actually, the future doesn't exist, right? The future is just the future, but we quite often project what we know from the past into the future. And then from that, it makes us either optimistic or pessimistic about it. But actually, the future can change. It can change based on decisions that you make now, but it can also change from things that happen which we don't foresee. So the future is not entirely uncertain. We quite often plan for the future. For example, today, you actually knew ahead of time that you were going to attend this webinar. I knew ahead of time. I knew about a month ago that I was going to be speaking today at this particular time. So we can actually have a certain degree of certainty through a certain degree of planning. So when you look at the definition of the word plan, it can mean what we as architects know it to mean, which is the top or horizontal view of an object or a map of an area. But it's also a method for achieving an end, some kind of procedure, a detailed formulation of a program of action, or a goal and aim. So in construction projects, it's actually all of these things. So we draw plans, we document plans, elevations, and sections because we are trying to actually determine what is going to be built in the future. So in a construction project, the purpose of the design is to translate the owner's aspirations for a building to be built in the future. So in the beginning, it's in the owner's imagination, or perhaps the owner's aspiration. Maybe they cannot even imagine physically what it might look like. And then it's the architect who then translates that from an aspiration into a concept that can be then translated into a physical form in the future. So what we do then is we document it in plans because we are not the ones who do the drawing. Sorry, we are not the ones who do the construction, we just do the drawings, because what we're trying to do actually is to communicate with another party, and that party has to construct it for an agreed price to a required quality and within an agreed time frame. So that's actually the fundamental of any building contract, to define the scope properly so that someone can price for it. All right, so how do building contracts address uncertainty? So this is the typical process of a project. Kathy also showed something quite similar earlier on, but this one is broken into 8 stages. So typically in the pre-design stage, the consultants or primarily the architect would be doing the research into the site conditions, authority requirements, and also liaising with the client to establish the brief and the project budget. Then after that, we start the initial design. We also do a project execution plan. So at that point in time, we would also advise the client on what other consultants need to be engaged. Then we do the schematic design, which is like the general arrangement layouts. In Singapore, we then submit those for development control clearance. And then we continue on to design development, where the rest of the project team gets involved. We will pass on our schematic design to the others to do their design development. And at that point in time as well, the QS would be doing cost estimates to make sure that the design meets the budget. And at that stage, we also submit for building plan clearance, which is the next level of detail to the authorities. And subsequently, we start the documentation for pricing purposes and also prepare the construction drawings. And then the construction starts. So you can see there's a lot of preparation beforehand, before construction can actually start. And you can also see that there's a certain overlap amongst all the stages. We don't finish one before we start another. There's always an overlap, and the degree of overlap will actually be dependent on the type of contract that you are using as well. And then after construction, of course, there's a completion stage, applying for the various statutory approvals for completion, and then post-completion, where we have to deal with defects and also wrap up the final account. So how a project is procured will determine how much of the design is done prior to going to tender, or also the other way around. You can also think about how much design should be done prior to tender, and then decide on the form of procurement that you want. So fundamentally, a lump sum contract is one where the contractor is taking the risk for the quantities. So because of that, most of the design is actually done prior to going to tender. So in this form of contract, the employer has more certainty of cost and quality, because the contractor would offer one price, right? Regardless of what the actual quantities are at the end, that's the price he offers. And also in terms of quality, we would come up with very detailed drawings and specifications. So for this form of procurement, we actually spend more time on design upfront. And then we would produce not only the general arrangement drawings, but also the detailed specifications prior to going to tender. And then at the end of the documentation stage is when the contract is awarded to a contractor. And why we have to have such comprehensive drawings is because we want to minimize the uncertainty of scope so that the contractor can price reasonably accurately. So this type of form of contract is most suitable for the types of projects where the employer wants to be able to control much of the design and be quite prescriptive about it. So we would tell the contractor exactly what we want and not give the contractor so much leeway to propose something else. Then if you look at a measurement contract, you'll see that the end date supposedly, theoretically, is a little bit shorter. And you can see that there's more of an overlap between the design development, documentation, and construction stages. So this particular type of contract is most suitable when the employer's priority is time and quality. So in fact, in Singapore, measurement contracts were very, very popular in the 1970s when Singapore was still very young and development was going at a much faster pace. So measurement contracts were used such that the architect would do the schematic design prior to tender, and then less detailed drawings would be provided to the contractor. The specifications would still be prescriptive, but you can see that the tender and award is actually sort of part of the way through documentation. So that means the documentation is not entirely complete yet. So the contractor gets like general arrangement drawings and maybe some of the details, but not all of the details. And the pricing is based on the bill of quantities. So very much is reliant on the quantity surveyors to come up with comprehensive bills of quantities so that the contractor prices based on that. And then the contractor uses the drawings just to understand the scope. And in fact, when construction starts, part of the design development continues as well as the documentation. So this type of contract actually compresses the entire process so that everything is happening simultaneously when you start construction. So you could be, say, doing basement excavation and basement structures here while the architect and the engineers are still resolving other details and continuing to provide the documentation to the contractor. So while it may seem that you can end earlier, sometimes it's actually quite a challenge for the consultants to keep pace with the construction. So there could actually be some delays because some details had not been resolved, and then it could actually result in some abortive work on site as well. In this situation, the contractor is paid on as-built quantities based on agreed rates. So the BQ would have the contract rates. So the employer is the one who actually takes the risk or uncertainty for the quantity and thereby the cost. Of course, there are different ways to control the cost. If you have a very comprehensive bill of quantities, then the cost uncertainty is a little bit less. But nevertheless, there's always a trade-off between the three variables: cost, time, and quality. You can't have cost, time, and quality all together. There always has to be a trade-off. And now, if you look at design and build, you'll see that it's even theoretically, it's even more compressed, and more things are happening simultaneously. And the design is done by the contractor. So now the employer is more concerned that he wants certainty of cost, and then he wants to supposedly save time, right? But it's actually debatable whether you actually save time. And there's little design done prior to tender. Sometimes the employer would just have written requirements and just provide general arrangement drawings. And then the specifications are mostly performance-based instead of prescriptive. So the employer actually has less control over the quality. And quite often the requirement in the contract would be that the contractor has to satisfy fitness for purpose. So as long as the end result satisfies the employer's purpose, then it's deemed to have met the requirements of the contract. And at the same time, if it doesn't satisfy the purpose, then even if the contractor had abided by the known codes and standards, he can still actually be liable for any failure. So in this case, the tender and award is done very early. So sometimes there is just the general arrangement drawings, and then the tender is carried out and then awarded. And from then on, the contractor continues with the design development and documentation. Of course, we have hybrid forms nowadays where the employer still engages full team consultants. Sometimes they are novated to the contractor to carry on the design development and documentation. Sometimes half of them are novated and half of them are not. In Singapore, quite often the architect and the QS stays with the employer, and then the engineers are novated to the contractor to continue with the design development. So why do people fight? In life, actually, people fight over two things. One is love, and the other is money. So in construction contracts, people won't be fighting over love. So the fight is always over money. And why it's such a complex process is because many parties are involved. There's so much expertise that's required in executing a project that it's impossible to do it with just one or a few parties. So even in the consultant team already, you would have a wide array of consultants. Even smaller projects require a lot of consultants. And then when you get to the construction stage, you have the main con, and then you also have many subcontractors, because the main contractor cannot be expected to have the expertise to do all parts of the construction. So when you have a lot of money involved and you have lots of parties involved, that's a recipe for disputes. So actually the main cause of disputes is miscommunication. When you talk about the different causes of disputes, for example, design brief not being clear or project objectives not being clear, it's actually miscommunication, because people can't tell what's in your mind. So right from the start, if you have an owner who cannot articulate what they want, then you already start on, you already starting on a not very firm footing. So the architect would often try to glean as much information from the owner as possible to make the brief clearer and also to understand the project objectives. Then we also have situations where the owner doesn't understand the design. That is also a form of miscommunication, because quite often we issue drawings, perspectives, etc. to the owners as we are developing the design, but they don't always understand the drawings. And I'll have to say, now we have such sophisticated tools and we can do really photorealistic renderings and things, but still we have owners who don't understand the design, and they can agree to things and then later deny that they've agreed to things, or they agree and then we go all the way to the construction stage and then they start doing a lot of changes during construction because they didn't realize it was going to look like that. Scope and role of each team member. So Kathy also mentioned that. The problem when you have lots of people on board is some things will fall through the cracks, because even if you actually define everybody's scope clearly, but there could be some things that you actually miss out. So the key to this actually is to be able to communicate to each party what they're supposed to do all the time. So not only in formulating their fee agreements, but also throughout the project to constantly work together to try and plug any gaps. Poor coordination. So again, because of the complexity, coordination is actually very, very difficult, because especially when the design is fluid. So when you make changes to a design, you have to actually inform all the parties involved that the design has changed. So during the design stage, the architect actually has to make sure the QS and the engineers all know that something has changed. And then when construction starts, you have to make sure the contractor knows, the subcontractor knows, everybody's got to know that the change has happened. Documentation, unclear, incomplete, discrepancies, unresolved details, that can also be because you chose the wrong procurement method. So just now I mentioned that for a lump sum contract, we actually need to produce comprehensive drawings to reduce the uncertainty for the contractor who is offering a lump sum price. But quite often we are forced to go to tender too early. And instead of using a measurement contract where we could have gone to tender with less detailed drawings, we are forced to use a lump sum contract, and then the tenderers actually get incomplete information to price on. So, again, that's a recipe for disaster. So actually choosing the right form of contract is extremely important. And of course, even if we produce a beautiful set of drawings, sometimes the builder doesn't look at the drawings. He gives it a cursory look, or he doesn't spot the discrepancies. Maybe he just looks at the structural drawings and then carries on constructing the structure. And then when he comes to do the architectural works, he realizes that the dimensions don't tally. So that actually happens quite a lot when people don't actually even look at the information that's given to them. Outcome does not meet expectations. This is also a miscommunication problem, because everyone has certain expectations for the project, and if the communication is not effective, then at the end of the project, it wasn't what you thought it was going to be. And a lot of these problems actually are the result of time pressure because of unrealistic time frames. Sometimes my pet peeve, I guess, is maybe project managers who are not really hands-on practitioners, who don't understand the technical aspects of the project, and sometimes they just give us arbitrary dates that we must meet, and that doesn't really help anyone actually. So it's actually very important to work through problems and to allow enough time for people to actually resolve things. Otherwise, we just rush on and then we end up doing abortive work. But on a sort of macro level, actually a lot of the time pressure is the result of our financing system, because developers often have holding costs. They take out loans and then they are actually paying financing costs, they are paying interest costs. So all this is actually tied to our current economic system, which is founded on GDP growth. So bear this in mind, because I'm going to be talking a little bit more about the economic system further down. The other thing is that our current system is adversarial. So we've inherited this from the British. Because it's adversarial, each is focused on protecting his or her own commercial interests. And quite a number of contractual mechanisms like EOT and LD are a zero-sum game. So there's always a winner and a loser. So it's very difficult to actually keep both parties happy. As the contract administrator, it's very difficult to get people to collaborate if there's always going to be one winner and one loser. Also, because of liability, parties are put on the defensive when something goes wrong. So instead of trying to solve a problem, then you will have this blame game, and then it goes round in circles. And instead of people focusing their energy on being proactive in solving problems, they then expend energy in actually protecting themselves. So I will give you a little bit of an insight into building information modeling from a user point of view. Actually, there is too much hype surrounding BIM. One thing I'll have to say is that it's a mistake to make BIM mandatory, because BIM on its own doesn't do anything. It's like any tool. On its own, it doesn't do anything. It takes someone skillful to make it do something and to deliver a good result. So if you think of any tool, a hammer, a saw, or anything, in the hands of someone skillful, it's quite different from someone not skillful. So it's actually more important for people to actually have the skill in using whatever tool they're using, and also to have technical knowledge. All of us in the construction industry must be technically competent. We must know what we're doing, and there's no replacement for that. So does BIM give us more certainty? So it depends on how you use it. So I will give you a little bit of a sneak peek into how we use it. If you remember my diagram just now of the different stages of the project, you will see that there was already a lot of overlap from one stage to the other. So actually, BIM makes the entire process very iterative. It's not you never finish one stage and go on to the next. So you're constantly refining the design in an iterative way. And because the software, we can use the software to produce perspectives, documentation, scheduling, analysis. So all of this actually can happen simultaneously. And it enables us to actually constantly refine our outputs and refine our design. But the most important thing is that we actually use BIM to make sure that the project team is working off the same base information. So what we do is we have a master file, and that master file represents the project objectives. And then all the information is generated from that master file so that everybody is on the same page. So diagrammatically or conceptually, it's like this. We have this BIM master file that we keep on developing as we go along. And throughout the different stages of the project, we will have different outputs. So we'll be generating the general arrangement at schematic design stage, doing our authority submissions, then generating our details, schedules, doing more authority submissions, then our tender documentation, and then construction drawings. So throughout this, the file continues to change. Then at the end, we will do the final submissions to the authorities to regularize anything that's changed in construction, and also make sure that what is submitted to authorities and the as-built drawings are all consistent. Just a note about having multiple parties use the same file. It's not always a good idea because there are many different types. We actually use different types of files, which I'll explain shortly. So just to illustrate, this is one of our projects. From this one file, we can do a perspective like this, photorealistic perspective. But we actually generate a lot of different outputs from this one file. And it's a bit like being multilingual. We know that in the industry, not everybody is using BIM or is proficient in using BIM. So we don't believe in forcing people to use BIM. We rather they use what they're comfortable with and solve the technical issues rather than get fixated on what tools they're using. So we can export in PDF, which everyone is familiar with. And we quite often export in AutoCAD because a lot of the contractors and subcontractors are still using AutoCAD to do their shop drawings. So what we do is we generate the AutoCAD outputs from our BIM file, our ArchiCAD file. So that gives them a base, which is from our file. So then we know that their base is correct, and then they can continue developing their part of the work with the correct base. And there's still a lot of people in the industry who like to use SketchUp. So from our ArchiCAD file, we can also export in SketchUp. Then it has this free viewer called BIMX, which is also by Graphisoft, which you can put in your mobile phone or your tablet. And this is a layman-friendly software. So we often send it to clients. We also send it to the contractor because most of the time the contractor also, if we give him 2D drawings, they can't imagine what they're building. So we want the contractor to be able to visualize what they're building as well. And then IFC format is for other parties who are also using other forms of BIM so that they can get the information and also the three-dimensional parts of the model in an IFC format without having to remodel things themselves. And then we can also generate schedules, not only in terms of quantities, but quite often it helps us when we're considering sustainability, for example. We can actually generate schedules as we are designing to see how much materials we need and how efficient we can make our design so that we consume less materials. So our approach actually is that communication is key, right? Communication is key to removing the uncertainty for the other party. So we don't really care what format we use as long as we can communicate to everyone, and we will give them information in 2D or 3D format or any format that they want, as long as they understand what they have to do. And again, you know, there's so much hype around BIM that there's so much emphasis on 3D that we often forget that 2D actually is also a very efficient way of conveying information. So we use tools to automate and speed up the process. And really what we think is most important is that we use whichever form of information is the most effective way to communicate. So, you know, as I said, we rather be multilingual than force somebody else to just speak our language. So we combine different software. So if ArchiCAD can't do something, then we'll use another software to work with it. So the key is actually to focus on what you're trying to resolve in the project and not get fixated with the tools that you're using. So our main objective actually is to minimize uncertainty for everyone, and then that will enable people to work with a certain degree of comfort, that they are able to, you know, look into their future and see what it is they're trying to achieve. And then this is something that we also did. This is a fabrication model. So yeah, another reason why it's not a good idea for many parties to use the one model is that because construction is so complex, the model is not always used for the same purpose. So you can have a model which is used for fabrication. So this particular one is a mass engineered timber building, and it has, you can see here, different pieces of timber coming together, and they're connected with steel plates. And then there are holes in the steel plates and holes in the timber for dowels and pins and plugs to go through for the connection. So these parts are often fabricated by different parties. So we model it to make sure there's no discrepancy so that different parties can fabricate this, and when it arrives on site, everything fits together. So this degree of detail we normally would not put into our model. So that's why I say it's not good for all parties to use the same model. You need to think why you're using that model. And then some parties, it may be appropriate for some parties to share a model, but not all parties. But the main thing is that For another party who is doing the detailed fabrication model, you have to export the right information for them to then take that model to another level of detail. If you want to know more about how we use BIM, you can click this hyperlink when you get the slides, and you can watch this short 15-minute video where we explain the process of how we use BIM. So in terms of communication, actually it is something quite timeless. Plato actually mentioned it in his book Statesman in the 5th century BC, that an architect is the ruler of workmen, and it's his business not only to pass judgment, but to give orders until the workmen finish their appointed task. So this is actually a timeless thing, right? Because so many parties are involved in construction, you have to be able to communicate what it is they need to construct. And likewise, in 80 to 70 BC, Vitruvius was born, and he became famous for writing 10 books of architecture. And he also talked about how the architect has to be able to not only ensure the propriety of his design, but also must be able to carry it into execution. So must be able to convey to the people downstream the information that's needed. And this is quite interesting. This is a hyperlink to a video which you can watch when you receive the slides. This is a medieval castle, but not a real medieval castle. It's being built in Paris right now. 200 kilometers south of Paris. It's being constructed. It's a project that started in 1997. What they're doing is trying to replicate a medieval castle, and they're doing it from scratch. So everything following medieval methods. And what they did is they used the same method of communication as the master stonemasons did in medieval times. So what they did was actually make a timber model. So you can see that if you were a stonemason and you had to carve, let's say, this junction, then you would know that your stone has to be at this angle and it's going to meet one at this angle. You know, so really it doesn't matter what you use. They didn't have BIM, they used a timber model. So the main thing is to communicate. Okay, so I will finish off by actually trying to look a little bit into the future and to consider whether it is actually uncertain, or whether we can have a certain degree of certainty. So the thing that actually helps us to have a certain degree of certainty is science, because science is based on natural laws. And if we look at natural laws, they can't change, and that will actually give us a certain degree of certainty as to what the future holds. This is a graph or chart from our World in Data, which illustrates our energy consumption from 1800 until 2019. So you can see that fossil fuels came in the early 1800s. And if you look at the amount of fossil fuels we are reliant on today, you know, a large part of our energy source is fossil fuel. And then even if you look at alternative sources like solar, wind, and the rest, actually all of these are reliant on fossil fuels as well, because we need fossil fuels to make or to mine the materials and to make the rest of the so-called renewable sources of energy are not really renewable because they are also reliant on fossil fuels. If you want to know more, this is a very good book to read. There is a link here which you can click to find out how to buy it. It's written by Alice Friedman, who has spent 50 years of her life studying energy. She got involved in the 1970s during the OPEC oil crisis. At that time, as a young woman, she thought, you know, that she would go into this field and learn how to solve our energy problems. But having been in the field for 50 years, she can tell us that actually the energy bonanza is over. We are so reliant on fossil fuels now. They are used to make 500,000 products. And when we first discovered oil, the energy return on investment was 100 to 1. So that means it took the energy of 1 barrel of oil to get 100 barrels of oil. So, you know, it was really easy. Right now, the global EROI is 17 to 1. And what scientists estimate is that when the EROI drops below 10 to 1, it will no longer be viable. So it's not that we can't get fossil fuels or that they're not in the ground. They are, but it will become less and less commercially viable for us to actually reach it. Okay, so we have this push for renewable energy. Is that the answer? Can we actually put solar panels everywhere and have all kinds of gadgets and things that are going to replace fossil fuels? So we look at some more data. So this is data from Simon Michaud, who works for the Geological Survey of Finland. And this is his report. And there's a hyperlink here. You can read it. It's 72 pages long. So if you don't want to read it, I've extracted some information. What he did a study of is the minerals that you would need to make all these things. So if we want to completely replace fossil fuels and we want to use electric vehicles, wind turbines, solar panels, batteries, blah, 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 what would we need? So if you look at copper, based on, this is the yield, this is what we need to completely replace fossil fuels, right? This column. And then this column is global production in the year 2019. And then this last column, the last column over here is how many years you need to produce the amount of material we need to make all of these things down here. So for copper, it's 328 years. Lithium is 16,121 years. Graphite, 12,015 years. And this is assuming that the mines don't decline in concentration. But right now, our mines are already declining in concentration. It's taking more and more energy and effort to actually get less and less material. So how realistic is it for us to be on this path to replace things with so-called renewable things? Actually, I find it really weird. How can all of this be called renewable when they are made from all of these things which are non-renewable? And then one last bit of data. This is by Gaia Harrington. You may have heard of this publication called Limits to Growth, which was a report to the Club of Rome published in 1972. At that time, computers were just beginning to be used, and a group of scientists actually used, basically they identified 5 major aspects when you take a systems view of the world, and they tried to simplify the model into 5 key aspects that we should look at and how they are interrelated. And then they came up with mathematical models, and then the computer generated different scenarios based on them adjusting something, based on what they observed as a current trend, what they think a trend might be. So as they adjusted things, the computer then gave scenarios of what could happen in the future. So that report was actually updated 2 times. The latest one was updated in 2004. So what Gaia Harrington did was she actually took the 2004 report, and since now it's 2022, so she thought, okay, what's happened after 20 years, right? How accurate were their projections? So she has actually looked at empirical data of what has actually happened since that report was released until now. And these are the 4 scenarios that she has called out. So BAU means business as usual. This one is if resources were at this level. Then BAU2 is if resources were at this level. And then CT is if we had comprehensive technology. And then SW is if we have a stabilized world. So we study it a little bit more closely. So this is where we are, the year 2022. So these 2 scenarios actually align very closely to empirical data now. You can see that the pattern here and here are actually quite similar. But what happens afterwards is actually very different. If we continue with business as usual too, that means the green line is industrial output. So if we continue on this GDP growth fixation, and we keep on pushing our industrial output up and up and up, if you look at what happens to food production here, there is a very sharp decline after 2030. So right now we're already here and it's already turning downwards. Assuming that if we had, okay, for comprehensive technology, if technology, let's say we got magic solutions and we managed to have all kinds of technological solutions, there is still a decline in food production after, but it may come up again. It may. But if you look at Simon Michel's numbers, how likely are we to be able to solve everything with technology? And then actually the stabilized world is the one we want, right? Where population will not decline sharply, it will stabilize, and then we will still have food. This is what we want. But it actually aligns least closely to empirical data now. And you can see actually what we need to do is actually flatten out our industrial output. So we have to actually stop producing so much and consuming so much. So BAU2 shows collapse. Population will decline sharply because we will be short of food. And then CT shows there's a bit of like what's going to happen here, don't know. And actually, the SW situation is the best, is our best bet. And right now we are not too far away to be able to turn around, right? 2022 is here, so it's following, like right now we're actually pushing here, but we can actually turn around and follow this more closely and hope that we can then achieve this kind of thing. And pollution, you can see pollution levels will also ease off. But you know what I think is that if you look at Simon Michel's numbers on the resources available, even if we don't intentionally flatten out our industrial output, I guess nature will force us to do it because there just won't be enough resources for us to continue pushing up the way we have been. So it's actually just a matter of time. These are not crystal balls, you know, these are actually just mathematical models, but they do actually inform us a lot because they're based on nature and they're based on the system's relationship amongst all these 5 variables. If we continue with business as usual too, we keep pushing for GDP growth. Actually now we are reaching a point where it's very difficult to turn back. So we keep pushing by 2050. If you think about Singapore, we say we want to achieve net zero. Net zero is not even really zero. It's kind of a creative accounting. But if we wait until 2050 before we wake up, look what's happened. The food production is already declined. So actually, I think by 2030, we're going to see you know, major shortages in food. So we really, really need to rethink the SG Green Plan and recalibrate and look at data like this. Right, so GDP growth, why are we pursuing it? Basically because of credit.
Sorry, Catherine, to interrupt, but I think we really need to wrap up because there are a couple of questions in the message box we'd like to get out to the forum. So thank you.
Yeah, I'll just finish off. I'll leave you to read this yourself. It's a debt-driven economy. So, you know, we can't just keep going until the music stops and then we'll find out who doesn't have a chair. So I've actually just put up some questions here, which we can put or try and discuss during the Q&A. You know, uncertainty actually makes people cling to what is familiar. But the further into the future, the more certain that there will be less energy and resources than we have today. So how will the economic system change? And will forms of ownership evolve? What will happen to the design process, the procurement process, and the construction process? So is it doomsday? No, I don't think it's doomsday, because again, if we look at what is timeless, actually in nature, collaborative behavior ensures survival more than competitive behavior. So the answer lies in actually collaborating more. And also looking at timeless qualities like self-reliance, resourcefulness, and adaptability. Good communication, a willingness to listen to and cooperate with others. And of course, we must have a healthy respect for nature. That's a non-negotiable, and that will enable us to find the answers. So sorry to take up more than my allocated time, but I hope that you've gained some insight into this, and I hope you have lots of questions. Thank you.